Okay. So it was mentioned earlier that there's a little bit of work done on also being able to output an HDF version of the ORSO structure. There's the text format output that has the YAML header, or you can map all of the metadata and data into an HDF file. So this is just a quick overview of one implementation that we've got for that so far. It contains the same information that's in the ORT file. If you have the correct branch installed of ORSOPy, you can write these new files the same way you write the .ort files. Just create your structure and then save NeXus instead of save ORSO. So there's a couple of points to make here that this is it doesn't overlap a lot with the existing NX-REFL application definition. So people who know about NeXus, there are these application definitions. Some of them are very detailed, like NX-CANSAS. And there's a sort of a smallish NX-REFL application definition that was created many years ago. And just because our current structure of the way that the ORSO information is laid out doesn't really overlap very well with what existed before, this doesn't at the moment use any of the NX-REFL application definition. Some mapping could be done. I don't know how useful that would be. And because this is a reduced data file, very different from the earlier presentations on raw data files that use the NeXus structure, the base classes in NeXus are largely designed for use with instrumentation information. So the monitors, the motors, the detectors. And so we're mostly just using the NX data folder from NeXus. So this is a very minimal mapping onto the NeXus namespace for reduced data, not for raw data. And then there's some documentation already available on GitHub if you wanted to look at what this mapping, so the sort of the same information that's in this presentation is also available as a markdown file on our GitHub. So writing the data sets to HDF5, the ORSO dataset is the top level HDF5 group. And so you sort of lay out a bunch of, an HDF file has a folder structure, and there's a limitation on that I'll mention in a moment. So the top level folder is the data set, and then below that is the info, and that's all the metadata that's in the header object in an ORSO data file, or an ORSOPy object and in an ORT data file. And that has all of the classes underneath it. And so the way those are being denoted here in the HDF file is that an attribute is added to each of these groups that is the ORSO class. And so this is something that sort of could become an application definition in NeXus down the road if we wanted to finalize this and sort of standardize this structure. So these would form sort of the basis. This is where NX-CANSAS comes in, and they define all their classes with these names in here. And then when reconstructing an ORSOPy object so when you deserialize, when you read one of these HDF objects back into ORSOPy, it uses these ORSO classes in order to decide which class to instantiate from the information inside it. And then the actual data that was TSV or CSV columns in the data file in .ort is written as data sets inside a group in HDF5. And then there's a kind of a limitation with HDF files. You can't have anonymous lists. I don't know if it's a limitation, it's just a design aspect. And so in order to handle things that in our data structures are anonymous lists, like we have a list of columns or we have some other lists, to map those onto something where each sub-item has to have a name, then you can sort of assign arbitrary names. These ones, the name of the columns is actually pulled from the name attribute of the column in the ORSOPy object, but it's not required there. And you can instead just give each object a unique sequence index attribute, and then this can be reconstructed into a list after the fact when you read it back in from the HDF file. So again, this is what happens in the header. Every header subclass becomes HDF5 groups. So in ORSOPy, you would create a data set. It has an info header, and then data source is one of the classes in there, and then experiment. And that becomes this path inside an HDF file. And so that's the group where you would find the same information. And as I mentioned, there's special handling for Python lists. And then for everything else, the attributes that you would write, all of the values that you write from the ORSOPy object are written to HDF5 data sets, where they map directly onto data types mostly that exist in HDF5. There's a special data type for none. This is something that exists in HDF5. You can make an empty data set with shape equals none, and that reads back into null or none when you read it back out. And then datetime objects for everything in ORSOPy that can be a datetime has it says it can be written out as a datetime object or in ISO 8601 string. So in this case, we make the conversion before writing it to the file. And then enums just become their base class. So this is sort of, this is a very detailed look onto what happens there. But in the end, so this ends up creating your HDF structure here. And then the folder that we add for NeXus specific information here is an NX data folder. So this is added on top of the upper groups map the ORT structure, and then this bottom one is a new one that is sort of plotting information for NeXus. So this is the NX data class, and it includes links to the columns that are in the data folder there. So these have slightly different names, unit versus units. There's a couple inconsistencies between the way we do stuff in ORSO and the way that the NeXus structure is laid out. And so having this separate folder that just links into the ORSO structure gives a lot of flexibility to do sort of both things. And then an immediate benefit of writing out these things into this NeXus structure is that there are free tools for visualizing NeXus files. There's NextPy, and then there's also the Panos tool, H5 Web, that lets you read them directly just from a browser without installing any software. And if your data is publicly accessible, like these test data sets have been posted online with a URL, and you can visualize them directly in the viewer there. So this is the Panos viewer, and so these are each data set that's defined has this little NX label on it, and so you can show the data sets from both. So there's two entries in here. This is a polarized data set, has plus plus and minus minus. So you can see up here it says down and up, and those are the two data sets that are in there. And then all the header information is in here, in info, data source, experiment, measurement, instrument settings, incident angle, for instance, min, max, unit. And then there's also the columns here, name, units. So this is the metadata for the columns, and the actual columns are here under data. So there's the QZ column, the R column, and then the various error columns. So that's what I have for the mapping. Thanks.